So it was asked in June, July 2016 for 6 months. Hopefully, you can solve this. Using source transformation, find the current RL in the circuit shown. RL is here. I will give you the hints. So in the notes, the space is provided. Take a print of it and solve it by your own. So I will give you a hint here. So convert this into current source in parallel with the resistance, current source in parallel with the resistance, current source in parallel with the resistance. Three current sources will be in parallel, directions will be same, so that the result is added result. And 5, 12, 4, they will be in parallel, so calculate its equivalent resistance. Finally, you will be having one current source, equivalent resistance, and the 100 ohm 10 ohm resistance. Again using current division rule, we can calculate current through 10 ohm resistance here. Current through 10 ohm resistance. All right. So solve it your by own and update the same in the notes. We solve the next problem. Using source transformation, find the current I1 through 5 ohm resistance here. Find out where is 5 ohm resistance. Okay. There are two 5 ohm resistance. One is here, another is here. But I can say current through this 5 ohm resistance should be calculated because they have mentioned one more term here as I1. So that this 5 ohm resistance should not be disturbed and it should be kept as it is. Okay. And here one more 5 ohm, 5 ohm or 5 ohm resistors. Out of 3, I do select this 5 ohm resistance because current I1 is flowing through this 5 ohm resistors that is given in the figure here. All right. So keeping that point in your mind, 5 ohm resistance should not be disturbed. It should be kept as it is. Now, first step is, you can see amperes of current is in parallel with the 10 ohms of resistance. These two can be converted into a voltage source in series with the resistance. All right. That will be the first step here. So these two things can be converted into voltage source in series with the resistance. All right. So what is voltage here? Voltage equals to I into R. I is 1 into 10. It is 10 volt. So you can see here current direction is this one, so that positive polarity should be followed according to this. Then 10 ohm is kept as it is. Next, it is simple thing. 10 ohm resistance and 5 ohm resistance, are they in series? 10 ohm resistance and 5 ohm resistance, they are in series, so that these two can be converted into single, that is 10 plus 5 is 15. All right. Next step is again convert. uh, Let us convert voltage source in series with the resistance into current source in parallel with the resistance. So this 5 is kept as it is here, and 15 is kept as it is. Current I is equals to V by R. V is 10 divided by 15. It is 2 by 3. Current direction is towards positive polarity of the voltage source. That is written here. Similarly, can you observe here the voltage source in series with the resistance can be converted into current source in parallel with the resistance. Same thing. Use the Ohm's law. 10 divided by 5 is what? 2 amps. Then 5 ohm is connected in parallel. All right. Now this 5 ohm should be kept as it is between the nodes C and D. Then 5 and 15, they are connected in parallel. So equivalent resistance of is 5 is in parallel with 15. We can use a calculator, that is 5 into 15 divided by 20. 5 into 15 is, we can give the answer 75 divided by 20, that is 15 divided by 4 ohm is the result. Hopefully all of you got the same answer. And you can see here, 2 ohm, 2 amperes and 2 by 3 amperes, they are in parallel, and observe the directions are same, so that these two should be added here. 2 plus 2 by 3, that is equals to, LCM is 3, 6 plus 2, that is 8 by 3 is the answer here. You can observe. All right. Now, what is asked? What is asked now? Find current I1 through 5 ohm resistance. All right. Find current I1. Can you apply current division rule for this? Two resistors, they are connected in parallel, for which a total current 8 by 3 is provided. So current I1 through 5 ohm resistance, the formula is current I1 equals to total current 8 by 3, opposite resistance 15 by 4 divided by total resistance, that is 15 by 4 plus 5. Can you give me the answer? All right. Hopefully all of you got the same answer, 1.142. Good. Right. So it is a simple problem. So, and it can also be calculated using voltage division rule. So voltage division rule, that is, okay, so convert these two, convert current source in parallel with the resistance into voltage source in series with the resistance. So total current I1 equals to, it is V by R, V is 10 divided by, V is 10 divided by a total resistance. Total resistance is what? 15 by 4 plus 5. So which you feel convenient, that method can be applied. Okay, good. So we go ahead. See here, using source transformation, find current through 5 ohm resistance. It was asked in VTU question paper, December 2019 and January 2020 for 6 marks. Where is 5 ohm resistance? Here it is, across which current flowing. Find the current through 5 ohm resistance should be calculated. So solve it by your own. I do give you hints. First, convert 30 ohm in series with 3 volt into current source in parallel with the resistance. Later, 30 ohm and 20 ohm will be in parallel. Again, convert current source in parallel with the resistance into voltage source in parallel in series with the resistance. Finally, we'll be having one 5 ohm resistance and R equivalent 5 ohm and this voltage. It should be calculated. Then current is flowing in this fashion. It is I. Then I should be calculated. Tell me your answer in the next class. If you are facing any problem, means I will solve it once again.